So we have a few of our pieces now, right? We put together, we have a good classification pipeline. We know how to find some, replace some entities. Um, um, and, uh, and we can pre-process our text. So there's a few interesting things. So now what we want to do is we want to put this all together so that it meshes very easily. And this is a bit more about software development and following good design patterns than about machine learning in general. So we put together our both entity replacements here. So just to keep in mind, this is not, again, this is not about returning the right answer. So we're still doing intent classification, but we want to have that pipeline put together so we can classify them properly and in steps. So first we have, if you're familiar with OO patterns, you'll know this right away. It's something called a factory pattern. And this is useful when you need the same thing. You want to reuse the same thing again and again, but like slightly modified. And in our case, that's the user query, right? So first we try it out on just the raw query that the user said, and then we try it out on the pre-processed one, and then we try it out on like, maybe we replace the entities and try it out again. Maybe we correct the typos and try it out again, and just this like same process. It's the same string, but just slightly modified. So a nice way to do that is to have something called a factory pattern. And it's just different versions of the same string put in a class. And you call the function and it returns that version. So you call, let's say, sanitized or pre-processed, and it calls pre-process on the raw text and returns it again. Same with entity replaced. I haven't put in the typo corrected version here, but that could be something you want to do for your bot. Maybe you want to do both pre-processed and entity replaced. And that's just calling the methods one after the other, and just saving it away in a nice little variable, so you can access it again and again if you want. And it may seem a lot of like boilerplate code, but actually it'll end up saving you a lot of time at the end, and a lot less debugging, and just like these nice abstractions can just help you find bugs very easily. Okay, so we have our text factory that gives us different versions of the same query. Now we want to put our classifiers together, right? Because we have different ones. We've looked at 4 different ones now, and so you want to put them together and run them one after the other. And that's where you want to use something called a builder pattern. And a builder pattern, just as the name implies, it just puts things together and runs them one after the other. I have add classifiers and query, so that's just putting stuff in a list. So this could be different versions of the same query, right, or same text that we saw in the text factory. Classifiers, this could be each a different one that we had defined previously. And when you call build, it just adds them together, and puts them together into a list, and runs and calls the predict function for each classifier. And until you find, until the prediction isn't like an unknown, you keep going, and then if it's not an unknown, you return the prediction. Actually, it's just supposed to be, you don't want to return run, we want to return. We don't know what the prediction is. That's our builder. And again, this is also just like good design practices to follow when writing code that gets this complicated. Here, it's also just, I just copy pasted the same class again, just to look at it. Nothing different going on over here. And similarly, like we had different classes for the pipeline, we just put our classifiers into classes as well. And it's nice because if you share the same interface, you have the same predict function, you have the same kind of initialization, you can like pass them around and take advantage of inherited classes and object-oriented stuff. It's nice to have these, have it written like this and modularized like this. And this is like, I'm not actually like, there's no extra code. We already have seen this before in the beginning part. Actually, it's supposed to return. These, and then just over. So we have our classifiers, we initialize them, and then we have a predictor class. You make a text factory, you take in a query, you make it a text factory, you make a pipeline, and just add different classifiers, call build, and return the prediction. And this just looks, there's probably more refactoring you can do to make this even simpler, but this is a good point to get started and take a look at what's going on. And it's very easy. You can just add the classifier and just a different version of the same class of the same query and pass that around a bunch of times. And so once you finally have that, you can make a predictor and call predict. Oops. Okay, so we modified that class, which is why it's complaining right now. So I'll set this back to what we had before so that to return only one, so that the code works as is. Rerun these cells again. We're just returning the replaced version of the text, not the entity itself, so we can double fetch on that. Okay, now our pipeline is set and it returns. And the advantage of this is, if you want to write another classifier, you just have to follow this API and have a predict function and add it another line here that does some other kind of classifier. And then you have a pipeline built. Okay, so the next task is actually give some people some time to work on what they're interested in. So it doesn't necessarily have to be this one. You could put together a pipeline for your particular bot if there's any other kind of classifier that you want to return, or if you haven't worked on this part yet, you can take some time to work on that now. Or another thing that might be interesting more to you is to work on some of these other workshop tasks, like working on disambiguity intents. So instead of returning, I don't know, return, did you mean X or Y? Or returning or correcting typos and adding that typo to your to this part of your text factory class, so that now it will correct typos. Okay, I think we'll move over to the next bit of the workshop. So once you have all of this put together, now maybe you want to have like some more advanced features. So so far we looked at how you might want to extract parameters, and looked at the food one. So what kind of food. Depending on that, you query some API and returns some results of restaurants or whatever. We looked at the directions one. If you can find location placeholder, location or places, then you can return them properly as well, and return directions for them. And other things to include might be typo corrections, correcting place names automatically, and then running into classification on them. But you might want to do some more advanced things like context, and maybe it's directions, but from one place to another, right? Maybe in the first part of the conversation, you only catch to, but not from where, and that's something you want to implement context for, and keep that memory around for a few turns in the conversation, so you can classify that properly. Or some more advanced features, right? Maybe you want to do small talk. And so we looked at this, we talked about disambiguating intent. So, instead of saying, I don't know, you say like, what do you mean this or that? Maybe there's some prediction that doesn't fall into, that either. Like, oh, well, yeah, it's just completely like the threshold isn't even close, or the probabilities are so low that the model actually doesn't know what this user query meant. So in that case, you might want to trigger something like small talk. And with the sort of setup we have now, you could add another component to the pipeline that says, oh, well, if all this is small, then if all of these, the pipeline does, if all of these fails, then finally you come to the small talk module that the prediction of which is just like an answer. And you can train like a sequence model for this with any kind of public data set, and return the answers from that sequence model. So these are some of the things to play around with and work on with this, with making good chatbots. And this notebook sort of sets you up for that. So you can keep adding these modules and keep improving. And it seems very small, like all these different things that we did, like, oh, we just added like very small things, but they accumulate really quickly. And the end user impact is more significant than we realize. I just noticed my screen sharing was paused this whole time. So I'll just show my slides again. Okay, yeah, that was the bit about extracting parameters with food, getting directions using location parameters, correcting typos, doing context, so directions from one place to another, or if you want to do small talk, where you don't want to return I don't know, instead of I don't know, you return something that's based on a sequence model. And with that, we end our practical portion of the workshop. And I think if Max can come back, maybe we can take a few questions.
Sure, I'm here as well, if there are any questions.
Yes, there are. So we have a few questions on Slack. The first one would be, consider this as an example scenario. When I perform the below line, I'll give it to you in a second. Well, I don't know if this is actually answerable for you right now, but the matrix return values are not the same as a SEER. And he's talking about this interplot confusion matrix. Why do like training on the same data sets will result in different values, Asir? We do have a lot of answers to this question, but maybe you want to say something from your perspective as well.
Yeah, sure. So just in general, when you train neural networks, at first they're randomly initialized or initialized to zeros or something. And the final weights that you get back and from as output from the model, or the activations you get as output from the model, um, they don't necessarily have to be the same numbers to get you to the same prediction. So even if two models have been trained with the same data, the same number of epochs and same optimizer, they can come to local minima at a different point.
Cool. And we have another one. So with text classification interpretation, we could see which class has the most or which classes have the most intersection. For example, class A, mostly misclassified class B. And then we could examine whether training data is correctly labeled. So he's asking, the labels seem fine, but the result still shows that class A mostly is misclassified with class B. Any suggestions about how to handle that? You can maybe read along on Slack. I'm just reading the Slack questions.
Yeah. So just so I understand the question properly, it's saying in the text classification interpretation that we looked at for Hilbert, the confusion matrix showed that one class was confused with this other one. You looked at the training data and you saw that it was correctly labeled, but it's still misclassified. Well, this because one part of it is because the prediction is based on the validation set and not your training set. So this confusion matrix is not on your training set, right? So you have to go back to your training data and sort of add those similar kinds of examples that the model failed at when you looked at it in the confusion matrix. And when you add those examples and then you retrain the model, and then it learns those and ideally makes the right predictions. Max, do you have something to add to that?
No, I think that makes sense. And also, I mean, from a more technical perspective, that's definitely the case. And also, I mean, the example here was probably quite simple, so maybe what I have to say doesn't really apply to that one. But I think looking at those kind of confusions can actually also tell you something interesting in terms of designing your chat as well, because you might actually realize that two of your intents are very similar, or maybe that, like, depending on what the metrics tell you and how you interpret them, you might actually realize, hey, I have one intent, which actually there's very different ways of people are asking it. And this might lead to certain confusion with another intent. Maybe it actually makes sense to split out and create yet a third intent, and treat that completely separately as its own class. I don't think it exactly answers that question, but it kind of touches on something similar. So I thought it's worth mentioning that. Like, just looking through those confusions and all the other metrics you get beyond just one simple accuracy number, it tells you a lot about like how you should proceed with designing both your models, but also designing the chat itself.
That's a very good point. Another person also answered, Mike said that check the balance of your classes. It's possible that you have a data set that is very imbalanced in terms of classes, and this could be also like a source of misclassification, as well as hyperparameter tuning is almost always required, he says. Those are all good points. Maybe one more question. Suppose your chatbot had to handle a very big list of hotels. So there needed to be two classifications per input string. A question, for example, when is the checkout? And B, the hotel, for example, the Prince Hotel in Shinagawa. Is the easiest way to handle that to have two classifiers working in parallel?
I think if I saw the responses on Slack, it was already sort of answered because I think the question came up before the second part of the workshop when Asir went into the named entity recognition. So I hope like whoever asked that question, maybe they can come back and say if that answered their question correctly. But probably the best way of doing this is really first you just have like the simple intent classifier, which tells you, okay, when is checkout or whatever you're looking for, and then you also have the hotel name as a parameter, and then you have the intent when it's checkout, and because you've identified that parameter of your hotel, you can then look up the correct response for that particular hotel. I hope that answers the question. Asir, do you have something to add to that?
In a different, maybe a slightly different scenario might be that they are two different um, chatbots entirely. So you have one bot for this one particular hotel. So you always know, because you know where the bot is located, you always know what when someone says check in, okay, it's definitely got to be this place, because if I'm at Prince Hotel, I'm not going to ask what's the check-in time at the Sheraton Hotel, right? Um, so the solution might that be just to have some sort of way to separate your models out and branch from there. Of course, because it's the same domain, probably a lot of intents could be inherited again and again, or other parts of the module can be inherited. But probably the easiest way is just simple solutions, just separate it out as another bot. And you could model your corpus like that too. So you have multiple bots, but shared or unshared intents in the same corpus.
Great, thanks. One more software engineering question. So based on your experience, what are some important considerations to make these pipelines scalable? Lighter modules might be fast to load, for example, exact match or fuzzy match, could go well with serverless functions like AWS Lambda, while, for example, heavier modules like BERT could fit better with dedicated servers like EC2 with some like auto scaling on demand. What is your perspective on that, Asir? Do you agree? Do you have any other suggestions?
Yeah, it's a very good question, and that's a question I think everyone who's in the AI industry and is like thinking about all the time, how to make predictions faster, how to have these good things scalable. And um, I think you kind of answered the question, answered the make the answer in your question as well. So definitely in the beginning, I would say even for like a small classifier, you could do naive Bayes or neural network wise, you could just do serverless solutions, and that could be from AWS or any other cloud provider that does these small functions. You start it up once and you run it and then it's gone and you're done with it. Easier to maintain as well. So you can start off like that, and once you start to see like, oh well, my pipeline keeps growing and growing, so now I need like bigger machines and more resources and work on that. And then you want to switch to like dedicated instances that are up and running all the time and running your service. And also you might need to separate out some parts of it. So, for example, inference or making predictions, you always want to do on CPU because you can parallelize CPU pipelines. You can have multiple cores running different predictions, and whereas GPU only if you do a batch prediction, that's the only time where you get multiple ones. But you may not be getting so batch is harder to do because you may not be able to get requests that soon at the same time. Like you can't get 64 requests at the same time and then do a batch prediction and then return it, which is what you want maybe in a GPU. But for CPUs, even if there's a bit of a lag, you can just assign it to another core and run that prediction. So inference, you want to do on CPU. For training, yes. For our pipeline, for example, maybe like the naive Bayes one, we can just let it run on some simple instance or even in some of serverless solution. But for the GPU, for the distal BERT training, you just want to like have either another separate service for that or have some kind of job running solution. And the cloud providers these days, they provide a lot of these job running solutions too. So yeah, that's what I would what I would do at least.
Cool, thanks. Sounds good. I think we have a few more minutes. Just kind of as a wrap up, the notebook is shared in a repository, Asir, right?
Yes, the notebook is public, yeah.
Perfect. And Max, you kindly also agreed to share your presentation slides.
Yeah, I'm happy to share the slides. What's the best way of doing it? Should I just post them on the Slack channel or maybe upload them to Google Drive somewhere and share a link to that?
Yeah, that would be great. Or just add it to the repository somehow.
Right,
Way we can access
cool.
the link. And yeah, this session is recorded, so it will be uploaded next week on our MLT YouTube. And I leave the last closing words maybe to you if you have any closing remarks before we finally wrap up the workshop.
I don't really have anything. I just want to say thanks again for everyone turning up on a Saturday and listening to us ramble on about chatbots. I hope it was useful, and also thanks to MLT for setting this up, and also thanks Asir for doing most of the work here. Do you have any closing words?
Yeah, just to reiterate, like for everyone for showing up, and also for everyone who's been answering questions, like not just, I mean, Fawn and Trevor are here from Bespoke, helping us out, but also like a lot of the community members who stepped up and answered questions, and thank you so much for doing that. And I think as MLT, this is our first time doing like hands-on long workshop in this remote kind of setting. Um, so we weren't sure. We hope that we were able to deliver as close as possible to the in-person ones we usually do, um, and adapting with Slack and all these tools, so that everyone, regardless of their level, gets something out of it. So, and obviously, of course, let us know if you have feedback for future sessions and stuff like that. Thank you.
Perfect. You said everything that was important. If participants have any feedback, please share it on Slack with us. Thank you so much, Max and Asir. I think this was a really fantastic workshop. As you said, Asir, it was the first time where we actually tried to do interactive coding sessions that we usually do in a physical manner. So this was new to us, but I think it went really well. We appreciate your feedback to all participants. Thanks again, Max and Asir. Thank you to Trevor and Fan for being really amazing and answering all the questions super quickly on Slack. Thank you also so much to Yuvraj, who was also supporting from MLT side. And thanks to all participants, of course, for joining us today on this Saturday, as Max said. I hope to see you soon. Next workshops will be coming very soon, and also of course like our study sessions, please do join if you have time. So with that, have a great weekend everyone. I'll see you soon, and yeah, take care.